Hello everybody, it's Mrs. Pound and we are working on chapter 6.3 about light. And today's topic is from section 632 and it's how light travels. And our objectives today are going to be to differentiate between luminous and illuminated objects and contrast transparent, translucent, and opaque objects. Now, before we get into luminous intensity, let me just talk a little bit about light as far as the fact that light always travels in a straight line, okay? And we call those lines rays. So next to luminous intensity here, draw just a line with an arrow, a straight line with an arrow, and say ray above it. That will remind you that light travels in straight lines. Now, as far as luminous intensity is concerned, this has to do with projectors and flashlights and things like that when they are producing light, and even light bulbs. We notice that the light spreads out. It's still going in straight lines, but it's spreading out as it goes in those straight lines. And what you will notice is that the amount of visible light that is emitted, the luminous intensity is the amount of visible light that is emitted from a source. And as the distance from the light source increases, the intensity of light decreases because it is spreading out. Now, we're going to learn in science, when actually you get into physics more, I'm going to talk about a lot of inverse square laws. And this idea of light intensity also follows an inverse square law. Because what happens is that, let's say this projector is 1 meter away from a screen. The distance is 1 meter, and actually the amount of screen covered by the image that it projects will be 1 squared meter, because 1 squared is 1. Now, 2 meters away is 2 squared. 2 squared is 4. It will actually cover an area 4 square meters. If you move it back 3 meters, 3 squared is 9. It will cover 9 square meters on the wall. Okay? So we cover a larger and larger distance, or larger and larger area each time the further you move back. But there's only so much light coming out of there, and it ends more spread out, so the intensity gets less. The image is not as bright on the screen, it's not as sharp, because it's losing intensity. So 1 square meter out, the intensity is 1. 2 square meters out, it's 1/4 because it's covering 4 times the area. 3 meters out, it's 1/9 because it's covering 9 times the area. And so the intensity goes down is an inverse square. So that's what an inverse square law means, is we put 1 over the 9, we put 1 over the 4, we put 1 over the 1, okay? That's all that means. Now, luminous objects, moving on here, a luminous object is an object that emits light. It makes its own light. This is something like the sun. This would be something like fire that creates its own light, okay? Those are luminous objects. They must emit their own light. Most objects we know are illuminated objects. This is an object that reflects light from luminous objects. For example, the moon. And actually, most things we see in our classroom, probably, I'm looking around right now, everything except for the lights above my head are illuminated objects. The reason I can see them is because they are reflecting light from the lights above me or from the sun outside. Objects can also be transparent. We have transparent substances. This is a substance through which light is easily transmitted with no scattering. So these window panes back in the picture, they are transmitting light with no to minimal scattering. They're a little dirty, so they're probably scattering light a little bit, but we're going to say they're completely transparent. And some examples of transparent substances are glass, water and air. Now, water and air, if it's clean and pure, if it has things in it, then not so much. We also have translucent substances. This is a substance that transmits light but scatters it as it passes through. So these are things like frosted glass and wax paper, where the light goes through, but notice you can't really see the objects very well on the other side. The light has been scattered a bit because of the unevenness of this surface. And then there are opaque substances. This is a substance that does not transmit light. It absorbs and reflects light, and the light that it reflects, this apple, you can see that it's reflecting some red, some kind of yellows in there, okay, maybe a little bit of green. The colors that it reflects determine its color. So this apple in this area is reflecting red, so it looks red there. Here, reflecting more yellows, so it looks yellowish. So that is how we see color. Something is its color because of what it's reflecting. It's also absorbing some colors. So here where it's reflecting red, it's absorbing all the other colors. Okay, and so that's why it looks red. So our objectives today were to differentiate between luminous and illuminated objects and to contrast transparent, translucent, and opaque substances. So 5 questions, and we'll be talking a lot more about light.